Hello everyone, welcome to MMBS-111, Introductory Microbiology. This is mini lecture 10.4. We're going to be talking about interactions between the drug and the host. There are three learning outcomes for this mini lecture. First, define drug toxicity. Second, distinguish between drug toxicity and allergic reactions to drugs. And finally, explain what a superinfection is and how it occurs. So, drugs are going to interact with the host because the drug is administered to the host, even though the target is the microbe. So, there will be some interactions. We're always looking for selective toxicity, but sometimes that isn't possible, depending on the organism that we're trying to treat. And many of these foreign chemicals can harm the host. About 5% of persons taking an antimicrobial drug will experience some kind of adverse side effect. So when we're talking about toxicity, we're talking about a chemical reaction that is going to adversely affect certain organs or tissues within the host. So different drugs can be toxic to different structures, and that includes the liver, the kidneys, the GI tract, sometimes the cardiovascular system, or blood-forming tissue in the bones, the nervous system, respiratory tract, skin, bones, and teeth. Each of these different tissues can experience some kind of toxic side effect. An allergic response is different than a toxicity. When an individual is experiencing an allergic response to an antibiotic, that drug acts as an antigen, and the immune cells recognize that compound as an antigen, and an immune response is initiated against that chemical. So your eosinophils that typically address allergens are going to be stimulated. So you're going to get a heightened sensitivity to the drug. You're going to get typical allergic reactions like hives or rashes, respiratory impacts, potentially anaphylaxis. The allergy can be stimulated either by the intact molecule itself or by any metabolized substrates, those broken down components. Allergies have been reported for every major type of drug, but allergy to penicillin is the most common. Typically what happens is the patient becomes sensitized when they first encounter that antimicrobic, and then additional exposure is going to lead to that immune response that signifies an allergy. So our body is colonized by billions of different organisms, and those normal flora, that natural biota, they colonize all of our healthy body surfaces, and they are typically harmless or sometimes beneficial organisms. Sometimes they might be pathogens, but in very few numbers. When we take a broad spectrum antimicrobial, that antimicrobial doesn't just destroy the pathogenic bacteria, but it also destroys our normal good biota. And this can lead to what is called a superinfection. The organisms that were once small in population number now become overgrown and the predominant organism, because the normal flora have been removed, and now these organisms do not have to compete with the other natural flora that keeps them in check. This is frequently how C. diff infections arise, because Clostridium difficile is a natural organism found in small numbers in the human GI tract. But when we take a broad spectrum antibiotic, that antibiotic wipes out all of the good flora that were present in the GI tract, and C. diff survives. And because it doesn't have to compete with other organisms, it thrives and causes additional problems as a result of that. Other secondary infections can arise because of this as well. Vaginal infections are common after a series of antibiotics, because they wipe out the normal good flora found in the female vagina and the other organisms that are found in small numbers but can cause problems like Candida albicans then overgrow. So here are some examples of some superinfections. Lactobacilli in the female vagina are killed by the broad spectrum cephalosporin used to treat the UTI. Overgrowth of Candida albicans occurs, causing a vaginal yeast infection. Oral therapy with tetracyclines, clindamycin, or broad spectrum penicillins kill off normal biota of the colon. Overgrowth of Clostridium difficile invades intestinal lining and releases toxins that cause diarrhea, fever, and abdominal pain. So those are just a couple of examples of how use of antibiotics can wipe out the normal good flora on our body surfaces and within body cavities, and then those opportunistic pathogens are given an opportunity to overgrow and cause additional problems. In 2013, the CDC issued a threat report, and they identified a number of organisms that were of concern because they were so highly resistant to antibiotics, either the particular antibiotic that was used to treat them or a wide range of antibiotics. And scientists are really concerned that we have entered a period of time where antibiotics will no longer be effective against any organisms. The CDC estimates that 23,000 people in the U.S. die every year from infections caused by antibiotic-resistant organisms. Part of the issue is how antibiotics have been managed, which we've discussed. An additional issue is that new and effective antibiotics have not been developed in recent years, and many pharmaceutical companies don't see the benefit economically to developing new antibiotics because antibiotic resistance arises so readily that once a drug is developed, it almost immediately is ineffective. It's very time consuming to research and identify new antibiotics, and it can be expensive to develop. So pharmaceutical companies in recent years have been very hesitant to be involved in the development of new antimicrobial treatments. And that's the end of mini lecture 10.4. These are our checking in questions. Make sure you go through those and that you review the learning outcomes. Our critical thinking question: Mary has a urinary tract infection and is prescribed cephalexin for 10 days. After 2 doses of the antibiotic, Mary experiences nausea and diarrhea. Is Mary experiencing a side effect or an allergic reaction? How do you know? What should Mary and her physician be concerned about if the diarrhea continues? So think about that question and what you've learned through chapter 10. And then I would encourage you to come back here and check your answer on the next slide. And hopefully this video was helpful.